Yes, the metal core in liquid-tight flexible metal conduit needs to be grounded for lengths greater than 6 feet. According to Section 330.30 Flexible Metal Conduit Type LFMC Paragraph C, grounding, the rules are as follows. Firstly, flexible metal conduit Type LFMC shall be permitted to be grounded by connection to the equipment it serves. Secondly, in addition to the methods provided in 330.30 paragraph C subsection 1, flexible metal conduit type LFMC shall be permitted to be grounded by any of the following means: 1. By the metal frame of the building or structure. 2. By connection to any of the grounding electrodes permitted for grounding services. 3. By an equipment grounding conductor run with the circuit conductors inside the flexible metal conduit. And 4. By a grounding fitting threaded into the conduit at any point. Grounding of electrical systems ensures safety by providing a low impedance path for fault currents to return to the source, which facilitates the operation of overcurrent protective devices like circuit breakers and fuses. This helps to minimize the risk of electrical shock and fire hazards. When dealing with flexible metal conduit, or LFMC, proper grounding is essential due to its construction. LFMC typically consists of a flexible metal core with a liquid-tight jacket, and the metal core's conductivity may not be sufficient to reliably carry fault currents, especially over longer distances. Therefore, the electrical code provides specific guidelines for grounding LFMC to ensure that a safe and effective ground fault path is maintained. Section 330.30 paragraph C addresses the grounding requirements for LFMC, outlining several acceptable methods for achieving proper grounding. The first method, as described in 330.30 paragraph C subsection 1, permits grounding LFMC by connecting it to the equipment it serves. This means that if the equipment to which the LFMC is connected is already properly grounded, the conduit can be grounded through this connection. However, it's important to verify that the equipment grounding is adequate and meets the code requirements. The second method, detailed in 330.30 paragraph C subsection 2, provides alternative grounding means in addition to grounding through the equipment. These alternative methods include: 1. Grounding the LFMC to the metal frame of the building or structure. 2. Connecting it to any of the grounding electrodes permitted for grounding services. 3. Running an equipment grounding conductor, also known as an EGC, with the circuit conductors inside the flexible metal conduit. And 4. Using a grounding fitting threaded into the conduit at any point. Grounding to the metal frame of the building or structure is permitted if the building frame is reliably grounded. This typically involves connecting the building steel to the grounding electrode system, providing a direct path to ground. Connecting LFMC to a grounding electrode is another acceptable method. Grounding electrodes can include items such as ground rods, ground plates, or the metal underground water pipe. The specific requirements for grounding electrodes are outlined in Article 250 of the Electrical Code. Running an equipment grounding conductor, or EGC, inside the LFMC provides a dedicated grounding path. The EGC must be sized appropriately based on the size of the circuit conductors, as specified in Table 250.122. The EGC must also be connected to the equipment grounding terminals at both ends of the conduit run. The final method involves using a grounding fitting threaded into the conduit at any point. Grounding fittings are specifically designed to provide a secure and reliable connection to ground. These fittings typically have a threaded body that screws into the conduit and a lug for connecting the grounding conductor. When selecting a grounding method for LFMC, it's important to consider the specific application and the available grounding means. The chosen method must comply with all applicable code requirements and provide a reliable low impedance path for fault currents. It's also important to ensure that all grounding connections are properly made and tightened to maintain their effectiveness over time. In summary, the grounding requirements for liquid-tight flexible metal conduit, or LFMC, are essential for ensuring electrical safety. The code provides several acceptable methods for grounding LFMC, including grounding through the equipment, grounding to the building frame or grounding electrodes, running an equipment grounding conductor inside the conduit, and using grounding fittings. By following these guidelines, it is possible to ensure that LFMC is properly grounded, providing a safe and reliable electrical system.